properties of equality. You use these properties and you don't realize you're using these properties when you solve equations, okay? You don't really think about them as properties, but they are, and they're going to be used as reasons in proofs. So we're going to start with the addition property of equality. Okay, so what that says is basically if we have some number A, okay, we're going to use a lot of variables to represent this, is equal to some number B, okay? So two numbers are equal to each other, or two things are equal to each other. The addition property says that I can add the same thing to both sides of that equation, that A equals B, and it will still be an equivalent equation. So that means that I can take A plus C and add B plus C, and that means it's still going to be the same because I'm adding exactly the same thing to both sides of my equation. You know how when you solve equations, if you have like 2x minus 3, you add 3 to both sides? That's the addition property of equality. You're using it, you just don't realize it's a property. Is everybody okay with that? Okay, then we have the subtraction property of equality, which is very similar. If some number A is equal to some number B, if I have that equation, then I can subtract the same thing from both sides of the equation. It will still stay equivalent. So A minus C is going to equal B minus C. Just like when you're solving an equation. If you had 2x plus 3, you would subtract from both sides, which would be the subtraction property of equality. So far, so good? Okay. All right, next is the multiplication property of equality. And again, if A is equal to B, the multiplication property says I can multiply both sides of this equation by the same number, so A times C, and that would equal B times C. What you do to one side of an equation, you have to do to the other. Everybody okay so far? Then you have the division property. So guess what you're going to do to both sides this time? You're going to divide. So if A is equal to B, then A divided by C is going to equal B divided by C. The only thing here is you can't divide by 0, so C cannot be 0. Thank you. Everybody ready? Okay. Then we have the distributive property, and it says if A times B plus C, then A times B plus C is going to look like this. You distribute that A to both pieces, so it would be A times B plus A times C. You know how to distribute. We've done it before in algebra. Also, when we do some of these algebraic proofs, they say combining like terms, like to add a 2x and a 3x together, they call that distributive as well, okay? Substitution property, what does it mean to substitute? Okay, like in sports, if you substitute somebody, what are you doing? You replace them with somebody else, right? Somebody that's supposed to be equivalent, yes? Or if you're cooking and you want to make it a healthier recipe, they tell you to put in like applesauce instead of something else. I don't know. I don't make healthy recipes, but something like that, right? You substitute. You replace one thing with another. So if A is equal to B, sorry, my pen's not wanting to write right now. I'm literally trying to scribble on this thing and it's not doing anything. Maybe that's a sign. Okay, if A equals B, then A may be replaced by B in any expression or equation. So as two things are equal, you can take one and replace the other one for that. Then you have the reflexive property. Think about your reflection in your mirror. When you look in the mirror, what do you see? You see yourself. You see exactly what you are, right? Not the reflexive, no. In the mirror, yes, you're flipped around, but I'm just saying, you see you, right? It doesn't change. So for any real number A, using the reflexive property, we just say that A is equal to itself. Yeah, that's what it means, reflexive. It's just something is equal to itself. Then the symmetric property is going to be where we flip it. So if A is equal to B, using the symmetric property, I can just switch that around and say that B equals A. Okay, those mean the same thing. And then we have the transitive property. And we talked about this one the other day when we were doing the law of syllogism. Remember, I referred to the transitive property? And I said that if A is equal to B and B is equal to C, what would you be able to tell me? A equals C, yes. Okay. So if A is equal to B and then that B is equal to C, then by the transitive property, we can say that A and C are the same as well. Does anybody have any questions on any of those properties? We've used all of these before in equation solving. We just don't really think about it. Okay. Next, it says using these properties of equality. These properties of equality can be used to justify steps in solving an equation. Okay. And the proofs that we're going to do in this class are called two-column proofs. One column, two column. Your first column is going to be your statements. Your second column is going to be the reasons. You have to justify each statement with each reason. Also, you cannot skip a step. Think about instructions if you're putting something together. If you don't follow it step by step by step, you're going to miss something, right? It's not going to go together like it's supposed to. Yes? So when we're writing proofs, you have to write everything. You cannot assume that I know anything. When we write proofs, you have to be teaching me. So you have to take each step, lay it out, and then also you have to justify it. And to use what we can use, the first side is going to be the statements. That's what I just said a minute ago. And we'll see what it looks like here in just a minute. And then the right side is going to be listing the reasons that justify each step. Okay, you have to justify everything. You cannot assume I know anything. And what we can use as reasons are we can use definitions. We can use postulates, which we haven't even really talked about yet. We can use theorems, which is another thing we haven't talked about yet. And we can use properties, which we just discussed. Okay, you can use definitions, postulates, theorems, and properties as your reasons in a two-column proof. Now, all of the properties we just discussed are properties of equality, which means equal signs. There are a few properties that can also be used in congruence. Not all of them can be used with the congruent symbol, only a few of them. Is everybody ready? Sure. Okay. Glad to hear that. We're going to start with the reflexive property of congruence. So what I could say then is if I had some segment AB, the reflexive property would say that segment AB is going to be congruent to itself, to segment AB. Remember, reflexive means something is equal to itself. If it's the reflexive of congruence, then we say something is congruent to itself. For the symmetric property of congruence, we can say that if segment AB is congruent to segment CD, what did we do with the symmetric property? We just did what with them? Switched them. So we can switch that around and say then CD would be congruent to segment AB. We have to remember which ones we can use in congruence and which ones we can't, because that will help us know what steps to take next in our proofs. And then you have the transitive property of congruence. So, for example, if segment AB is congruent to segment CD, and that same segment CD is also congruent to segment EF, then using the transitive property, what two segments can I say are congruent now? Yes, segment AB is congruent to segment EF. They are both congruent to segment CD, so therefore they can be congruent to each other. Anybody have any questions? No? All right, flip it over. What do we see now? Our two-column proofs. It's not that bad. All right, so what we have to focus on is what's at the very top. We have to focus on what we're given, and then also what we're trying to prove. Okay, now these are easy because they're algebraic equations, or they should be relatively easy. Once we get into our geometric proofs, that's when it starts to get tricky. What we do first, every proof that we do, no matter whether it's algebraic or geometric, every single proof, oh, my stuff is not catching up with me, is it? Starts with the given information. Do you notice how that statement that they gave you, the 4x minus 1 equals 27, do you notice how that's listed first in your proof? Mm-hmm. Okay. Yes. Hold on. Come on. Not work, is it? Okay, let me write it down. You know what? Give me just a second. Just pause for a minute. I need to be able to do this on the screen. Let me restart and